Aloha and welcome. In this video, we're going to be talking about virtualization. So what is virtualization? Well, virtualization is the use of software to create a simulated or virtual version of physical computing resources. Virtualization is the foundation of cloud computing and allows for more efficient utilization of physical computer hardware through the creation of virtual machines, what we call VMs. So why do we do this? Let's say that you're a developer like I was at the last company that I worked in. I was working on systems. I worked predominantly in an English version of Windows. I think it was 2000. Maybe it was no, it wasn't 2000. It was Windows 8.1. So I was using Windows 8.1, and I needed to develop software for a Windows 2019 server running in Japanese. So for me, it was easiest to use a virtual machine. So when we think about our machines, we think about like for me, I was using a desktop, and my desktop had memory. It had a number of CPUs, and it had a network interface, and it had physical storage on it. I had quite a lot of it. I had spare capacity, you might say. So instead of buying a second computer and setting up an environment to run the 2019 server that I wanted to, instead, what I did was I used virtualization. And virtualization is going to allow us to create a machine within a machine. So this type is it's type two. I'll explain this in a minute, but the type that I was doing here was it's referred to as a type 2 hypervisor. It's a hosted hypervisor. So in other words, I had Windows on my system, but I was running this on top of it. So I was using Oracle's VirtualBox technology to do this. But what happens is I create a new virtual machine, and I provision it. And when I provision it, I say, okay, of the 16 gigabytes of RAM that I have, I want to allow you to use maybe 8 gigabytes of it. In essence, split it in half. So I want to use 8 gigabytes of this. I want to use maybe 250 gigabytes of storage space, and I want to use, one of my CPUs for it. So you can take that excess capacity that you have and use it for this virtual machine. And that's great because now instead of buying all this new equipment, I could run that extra computer and I could have several computers on there if I had enough physical computing resources, or I could have one run at one time, turn it off, and then I could turn on another one. And I could have multiple systems that I could simulate in here using virtual machines. So that's the beauty of this. It allows you to run multiple machines within a single hardware configuration. So VM, it's going to consist of three components. One I mentioned earlier is a hypervisor. The hypervisor is also known as the virtual machine monitor, the VMM, and that's going to be the software firmware that's used to virtualize the host machine's hardware platform. So a host machine is the machine used by a hypervisor to create a guest machine. In the example of my system, I had a desktop. That desktop would be considered the host machine, and the hypervisor would run on that host machine to create these virtual machines or guest machines. So a guest machine, the final of these three components, is a VM running on the host machine. So the host machine is the actual physical box. The hypervisor is the virtual machine monitor, and then the guest machine is that virtual machine that you're running. So a guest machine runs an operating system and is logically isolated from a host machine. So logical isolation is a virtualization feature enabling a guest machine to behave like an independent machine. Logical isolation enables a host machine to run multiple guest machines with OS-specific software. So on my system that I had, I could run Linux. I could run like Ubuntu Linux. I could run a different language, Japanese. I could run the Japanese language version of Windows 2019. I could, simulate all these different things on my one system that I had. So that was great. You've got, as I mentioned, two different hypervisor types. You've got type 1 hypervisor, which is known as a native or bare metal hypervisor, and you've got type 2, which is a hosted hypervisor. The difference is pretty simple. Type 1 is where you have, it's usually run on a server, and it's bare metal because you don't need an operating system. An operating system isn't going to be running this. Your hypervisor is going to run, it's going to do all the virtualization of the machines. So it's just directly, you've got a number of virtual machines on there. Type 2 is going to be hosted, so you actually have an operating system on there. For my example, I had, I think, Windows 8.1, 8.2, whatever it was, and I had, I had a hypervisor on that, which was Oracle's VirtualBox that ran the different virtual machines. So yeah, so that's the difference in the two. Type 1, just remember bare metal native. Type 2 is hosted. There's some trade-offs here and some considerations. So when you're talking about a Type 1, which is bare metal, that's a system that's built for virtualization, whereas in Type 2, like my desktop, it was predominantly for my development, but oops, I need this extra server system, this server environment, or oops, I need this database backend or something. I could spin those up. So I can kind of add that virtualization to a traditional computing environment. The difference, like Type 1's often server, Type 2 is workstation. The performance, you're going to get better logical isolation for VMs on a Type 1, and you'll get adequate logical isolation for VMs on a Type 2. And the cost, it's going to be more expensive if you're doing the server because you're going to have a beefier product there. You're going to have a lot more memory and resources for it. Type 2 is going to be less expensive than the Type 1 just because it's server desktop of differences there. And then something we have to think of, because we're talking about security here, when we're talking about virtualization, we need to be aware of virtualization exploits. So we have a couple different things we have to worry about. One is VM escape, and VM escape is a virtualization exploit where a process escapes a guest machine's logical isolation to interact with the host machine. That's not what we want. So an attacker uses VM escape to further exploit a host machine. So for example, if an attacker was if they got VM escape and they got out, they could delete, guest machines, or they could delete data or whatever they wanted to on that system. Another thing we have to worry about is VM sprawl, and this could be, if they were to escape and they were to do this virtualization sprawl, one thing they could do is, they could, let's say, create another VM that's going to consume all the, available resources. So if they were to do that, that would choke off the other VMs, and you'd have a denial of service essentially. So you want to be careful of that. So we also need to be careful of resource reuse in virtual environments. That's the sharing of resources such as your memory, I/O devices, and system components between the host machine and the guest VMs, or between the multiple VMs. So resource sharing improves the efficiency, but it can pose security risk without proper isolation. It can allow a compromised VM to access or manipulate resources of other VMs on the host machine. So you have to be careful of that. So an example of this would be like a vulnerability in a shared memory mechanism. It could allow an attacker to reuse memory resources and gain access to sensitive data, or it could inject malicious code into other VMs. So we have to be careful. Remember, use traditional mitigation techniques for both your host systems and your guest systems. Remember to keep them updated, keep them patched up, for the latest, changes in the operating system and everything. Also, you should host machines VMM should be updated to mitigate virtualization exploits, so that, for example, Oracle's or was it Oracle's I think it's called VirtualBox, yeah, Oracle's VirtualBox. Just make sure you update the software in case they've been informed of security vulnerabilities. You can update that and make your system more robust in that way. You also have to think about VM lifecycle management. We've talked about software lifecycle management before, but you also have VM lifecycle management. So that's the series of procedures where a VM is created, it's maintained, it's monitored, and then it's decommissioned when it's no longer needed. So at the end of it, when you're finished, doing this development or whatever else, you can destroy whatever you've got there. That way you don't have all these things that are hanging around and could be getting vulnerable over time as you don't apply security patches to it because it's a done deal. So do implement VM lifecycle management as well. And that's it for this section. Short and sweet. Virtualization. We're talking about virtual machines. It's got three parts: the hypervisor, the host machine, the guest machine. We talk about logical isolation that gives us the ability to do all of this great stuff. There's two types of hypervisors: type 1, which is bare metal or native, got the type 2, which is a hosted hypervisor. We talked about the considerations for both. And we talked about the virtualization exploits that we have to worry about. We have to worry about VM escape, jumping out of that logical isolation. We have to worry about VM sprawl or virtualization sprawl, where they eat up the resources for others. We talked about resource reuse and how that can be exploited. We talk about the general need for doing things like VM lifecycle management and just traditional mitigation techniques. Always update your operating system. Always have the latest things. Harden your systems. Lock down services that you don't need. That type of thing. So that's it for this section. If you have any questions, reach out. Otherwise, I'll see you in the next one. Aloha.